This video is meant for Mrs. Rose's AP Calculus class, and it is on volume by revolution with all the axes. So we already talked in the past about calculating volume with known cross-sections. Squares, semicircles, and equilateral triangles are the most common shapes that are used on the AP test. However, this video is focused on volume by revolution, where we're going to use circle cross-sections and revolve a function around either the x-axis, a line y equals a number, the y-axis, or the line x equals some number. So in general, we're using the cross-section of a circle, so our interval is going to go from a to b, and then we're going to have pi, the radius squared, and the radius is going to be whatever function you are given. When you rotate it around the x-axis, you're going to get a cone-type shape, but just that the end is cut off, and the x-axis is the dotted line in the middle. So on an example like this, we have the square root of x minus 2 between 3 and 4. So we're going to set up a shape revolved around the x-axis that it's not quite a cone because the sides are bulging, but maybe some kind of bowl that's on its side. So our volume equation is going to be the integral from 3 to 4, and we're going to have pi, and then we're going to have the radius, which is the function, squared dx. And then going through for the integration, we can square the square root, take the antiderivative, plug in 4, plug in 3, and we're going to get 3 pi over 2 units cubed. If you have multiple functions, we have to subtract out the area in the middle that's empty, or there's no solid there. So we're going to still use a circle formula from a to b, pi, and then the outer radius, the one that's further away from the axis of revolution, squared, minus the inner radius squared. Again, the inner radius, you're subtracting the empty area in the middle of your shape. For this one, our region is bounded by y equals 2, and the quadratic 4 minus x squared divided by 4, and we're going to rotate it around the x-axis. So we have a shape that looks something like this. In order to figure out our limits of integration, we're going to need to find these two intersection points. So I'm going to set the quadratic equal to 2 and then solve for x. Then I'm going to set up my integral from negative 2 square root of 2 to positive 2 square root of 2. I'm going to use my pi, and then I'm going to have my outer radius, which is the 4 minus x squared divided by 4 squared, and then I'm subtracting the inner radius, which is 2 squared. I did this one on the calculator, so we have pi times 42.37784, which is 132.694 units cubed. If we're trying to revolve a region around the line y equals some number, for example, the y equals some number is right here, we're still going to have the integral from a to b, pi, but the outer radius is going to be your f of x minus the axis of revolution. And we're squaring that. Then we're subtracting the inner radius, which is your g of x, minus the axis of revolution, squaring all of that, and then integration. Okay, so now we're going to look at if the region bounded by our two functions is rotated around a different line besides the x-axis, like x equals negative 1. When we rotate this, we're going to get a shape that has some empty space here in the middle, but that these areas here are going to be fairly solid. So our volume equation is going to be the integral from 0 to 1, because those are our two intersection points. And then we're going to have pi times the outer radius squared, which is going to be x minus the axis of revolution, -1. And then we're going to have minus the inner function, x squared, minus the axis of revolution, -1. When you do all that integration, you are going to get squared quadratics, like so. Remember, when you have the negative here, you should distribute the negative to all of these pieces, and then when you combine like terms, make sure your signs are correct. Integration, we're adding 1 to each exponent and multiplying by the reciprocal. Plugging in 1 first, then plugging in 0, and we end up with 7 pi over 15 units cubed. For this next example, our line of revolution, our axis of revolution, is moved up to y equals 5. This is going to dramatically change our equation because the function that is our outer function becomes x squared, and our shape looks like this. So our volume equation is still going to be from 0 to 1, and we're still going to have pi, but the first equation is going to go from the axis of revolution all the way to the x squared, and our inner radius is going to be just x. So we have x squared minus 5 squared minus x minus 5 squared, where x squared is the function further away from the axis of revolution, and x is the function closer to the axis of revolution. So our volume equation, when we square things, we're going to have x to the 4th minus 10x plus 25, 10x squared, minus x squared minus 10x plus 25. Combining like terms, we're going to get x to the 4th minus 10x squared, minus 11x squared, minus 10x squared, minus 0. And then we are taking the antiderivative, plugging in 1 first to get 23 pi over 5 units cubed. And then our final example, we have the line y equals -3. If you're trying to do this on your own, go ahead and press pause and try to solve this one and see if you get the same answer as me. You should get 17 pi over 5 units cubed. Now we're going to look at revolving the region around a different kind of axis. This one's going to be in terms of y. We're going to go around the y-axis. So since we're going to integrate around the y-axis, everything needs to be in terms of y. Alright, so the first thing I'm going to do is I'm going to change my equations and change my integral. So I'm going to go from 0 to 4, because those are my y values, and then I'm going to have my equation in terms of y, so the square root of y instead of y equals x squared, and make sure you have your dy instead of dx. Then we're going to square the square root, so we just get y equals 1/2 y squared, plug in 4, plug in 0, and we get 8 pi units cubed. For something like this one, revolving around the y-axis, we're going to need to change this equation to be in terms of x equals whatever we can. So to do that, I'm going to do a scratch pad work over here. So I'm going to square both sides to get y squared equals 16 minus x squared. And then I'm going to add x squared to both sides. I'm going to subtract my y squared. And then, since it's only in quadrant 1, I'm just going to use the positive square root of 16 minus y squared. And I'm going to integrate that from 0 to 4. So my integral is going to be my volume is going to be a hemisphere. Oops, I already did that. And we're going to put everything in terms of y. When you square a square root, the square root goes away. We're going to integrate. We're going to plug in 4 first. So we get 128 pi over 3 units cubed. Okay. When you have something around the line x equals -1, pardon the announcement, everyone, but since we have x equals -1, we are going to be rotating it with everything in terms of y. So we're going to need to have our equation in terms of y. That one's not too bad. Again, because it's in quadrant 1, we're just going to have the positive of the square root. And of course, x equals y is already y equals x. So we're going to integrate from 0 to 1 pi, and then our outer radius from -1 is going to be the square root of y minus the axis of revolution squared minus the inner function, which is y, minus the axis of revolution squared. And then you're going to have, let's see, y minus 2 square roots of x. Oh, just kidding. Not yet. Oh. And then we just integrate in the calculator and get pi over 2. Oh. That ends this video on the volume of revolution, volume by revolution. If you have any questions, please feel free to email me or see me in Chem Morning or after school. And of course, class. Good luck with your homework, and I'll see you next time.